Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on GeeksForGeeks for 30th April 2023. The problem statement for today is powerful integer. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says you are given an 2D array intervals whose length is n, where interval of I that includes start and end. That means all integers from start to end inclusive. Start and end are also present. Okay. And also we are given an integer k. We have to return the powerful integer. Powerful integer is that integer that occurs at least k times. If multiple integers have at least k occurrences, we have to return the maximum integers out of those elements. Okay, so here it is saying that we will be provided with one 2D array, and that means each element, that means each set in this 2D array will consist of a start and end. So it will kind of 2D array with element containing start and both start and end both are inclusive. And here we need to find the powerful integer. The powerful integer is the one that occurs at least k times. And if we are getting more than one powerful integers, then we have to return the maximum one. Okay, so this is the problem statement. And if in case, if no such integer occurs at least k times, then we have to return -1. Let's go through the given examples here. So the first example says n is equal to 3. That means the size of the 2D matrix is 3. That means 3 sets are there. And the interval matrix looks like this. So here it comes the first set, that means first set of start and end as 1, 3, second set as 2, 4, 6, and third set as 3 and 4. So here we have to find the element which is occurring at least 2 times. See here we have to consider all the elements in between the ranges also. So here the output it is showing it as 4. Here as we can see 3 and 4 are the two integers that have occurrences greater than 2. That means 2 are equal to 2 or greater than 2. So that means 2 greater than or equal to k. So we have 4 in this case as the powerful integer as it is the maximum element which satisfies the condition. So we are getting 2 elements here, 3 and 4, both which are satisfying the condition of maximum, satisfying the condition of powerful integer. But out of these two, 4 is the maximum one. That's why we have selected 4 as the output. When we look at the second example, here the size is 4 and given interval 2D matrix contains these sets. Okay, that is containing 1, 4, 12, 45, 3, 8 and 10, 12. And here the k is given as 3. So we have to find the elements which is occurring at least 3 times. So here the output is 1. As we can say, no integer occurs 3 times. So in this case, we have to return -1. Okay. So why we are returning -1? Because in note it is given that if no integer occurs at least k times, they return -1 in this case. So if you look at all the intervals even in between, so we will not find any integer that is getting repeated 3 times in all the intervals, considering both the start and end inclusive. Okay, so I hope the problem statement and the given examples are clear to you. So for solving this problem, initially I was trying to solve it with the HashMap. That means counting, that means iterating through the HashMap from left to right, that means through all the intervals, and then using another loop to iterate through all the elements in between the ranges. Then counting all the frequencies and checking that for which element the frequency is matching, which is greater than or equal to k, and if there are more than such elements, then return the maximum one. So initially I was trying with this approach. So let me try with that first. Also some problem is there in this one. Actually it was giving the time limit exceeded error. So okay, let me just remove the below one and this one. So initially I was trying with this. So in the first loop I was iterating through all the intervals. Then in the second loop, all the elements in between the intervals, that means where start and end point both are inclusive. then counting the frequency of each of them, then iterating over those map as entry sets. Then we check where the value is greater than or equal to k, and where the entry dot get key is the maximum, that is greater than maximum, so we will substitute the maximum one. So wherever this condition satisfies, then we return this one. So if you try compiling this code, so here you will get the correct output only. So see, here we have got correct output only. But when we try to submit this solution, okay, see, here it is giving time limit exceeded error. Because the reason is that here we are using two loops here. One is for the entire interval and another is for the interval within the ranges. So for some input where the given input size is so large, so that's why we are getting this time limit exceeded error. Okay, actually we need to solve it in expected time complexity is big of and log n only. So for some of the inputs which is very large in size, we are getting this output. So that's why I have not taken this this solution as the final one. So I have tried creating another solution. So in that one, the approach for that will be again I will be still using the map only, but with some changes. So the approach will be the approach for solving that problem will be to find the maximum endpoints among all the intervals. Then create an array of length max endpoint plus 2 to store the occurrences count of each integer. Then iterate through each interval and increment the count if it increment the occurrence count if its start point by 1 and occurrence count of its end point plus 1 by minus 1. Okay, so we will be incrementing the index of the starting point by 1 and decrementing the occurrence count of the end point plus 1 by minus 1. Why we are doing plus 1? That means wherever the element is ending, whatever is the end point, so we are not decrementing that value as 1 by 1, the value next to it. So that the only reason that both start and the end point both are inclusive. That's why. That means wherever the end point, that value is valid till that point in the count for the powerful integer. After that, we iterate through the occurrence count array and keep a running sum of the occurrence count. Whenever the running sum becomes greater than or equal to k, update the most frequent integer with the current index. Then return the most frequent integer. So this approach we will be following, not this one. So I'll just remove this code here. Yeah, but before moving to this code, let me just explain it with an example, that approach, whatever it would be. So let me move to this. Let me just minimize it. Yeah. Let me just try giving a tab here. Okay, it's not. Okay. So let it be this way. So I've taken this example where the size of the 2D array is 5 and we have these 5 elements and these 5 sets as the interval array and value of k is 3. So the approach which I have told for the second approach, which I have told which will be the correct solution for this problem. So first step was to find the maximum endpoint of all the intervals. So these are the endpoints 21, 8, 17, 29 and 24. So whatever is the maximum one is 29. Okay, so maximum endpoint, that will be 29. After that we will be creating an array with the length max endpoint plus 2. So this will be the entire array for max n plus 2. It will be initially it will be all zeros, but after that what we do, we iterate through each interval and increment the occurrence count if increment the occurrence count of its starting point by 1. So wherever is the starting point, if you look at the first starting point is 16. So wherever we go 16 will be plus 1. Wherever it is 5 will be plus 1. Wherever it is 12 will be plus 1. 17 will be plus 1, 9 will be plus 1. Okay, so the starting point will be incrementing by 1 and the ending point plus 1, that value will be decrementing by 1. So for example, this 8, if you count this 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so till this point something is valid. That means this 8 is getting ended here. So after that the position at plus 1, that means end point plus 1, so that will be 9. That will we are marking with minus 1. So that will be marked initially with minus 1, but later we have again one value starting at 9. So it will be like minus 1 plus 1, it will be 0. That's why it is showing a 0. But the scenario which I am talking about, that what I am trying to say, that whatever is the ending point plus 1, we are marking it with minus 1. So look at this one. This is 29 and we have created an array of size of 29 plus 2, that is end point this array of size 31. So whatever is the maximum value here, it will be, I am just marking it with minus 1. That means array of 29 plus 1, that value, because since it's the end point, that is being marked as minus 1. That means the value is decremented by 1. So initially it was 0, decrementing it by 1, marking it as minus 1. Okay. Similarly, if you look for 24, then at index position 25, it is minus 1. If you are looking at 21, that index position 22, it is minus 1. See, it is showing that how many numbers are active in this range. Okay, here we can say, since we have to consider all the elements in between the range, so here we can say starting from 5 till this point which is 12. From 5 to 12, one element, that means the count 1 is applicable for all the integers. So if the value of k was 1, so here we could have got the one answer. Okay, so it is indicating that point. So once we are getting all this, then and once we populate this entire array, then what we do, then we iterate through this occurrence array, this is the occurrence array, and keep a sum of the running count, keep the running sum of the occurrence count. So here we start from the left, we keep on moving towards the right. So here first we will get 1, then okay, we will have this value as 1. Then after that we get the value as 2, and after each value we will check if it is greater than or equal to k. So here we will get, again here at 12 we will get one value as plus 1. So here 1 plus 1, it will become 2. So here it will become here plus 3. Okay, 1 plus 1 plus 1 is equal to 3. Then here it will be 4. So after this, see here, from this point 3, when the sum becomes 3, so that from that range our solution is becoming applicable for the given k, value of k. So here the value of sum will become 3. So from this until the value gets lesser than 3, so all the elements in that range will be our valid powerful integer. Among those we have to take the maximum one. So here it will be 3, and the sum value will be 3. That is, so so the first input will be 17. That means the first probable output for this value for this problem will be 17. Then after that we are again incrementing by 1. Then after that now whenever it is the minus 1, we are decrementing it by minus 1. So the value it will be 4 minus 1, 3. That is still valid for us, because we have to check the maximum, the element which is occurring at all the intervals, that is having value greater than or equal to k. So after that we keep on moving, and till this point it is 21. That means this count is 21. So when we reach to 22, here when we reach to 22, so we can see that when we keep on doing summation in the running sum, so the value will now become from 3 to it will become 2, because 3 minus 1, it will become 2. So here till this point it was valid, that it was satisfying our condition where k value was greater than or equal to 3. But after this point the sum became 2, then this condition became false. So till now, whatever is the maximum value, so that was our output. So here the output will be 21. If you look at the index position, if you count from beginning, it will be 21. Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21, this is 22. Similarly, it will go up to 30. Okay. I hope this explanation is clear. So our output will be 29. So this approach is working because when we increment the occurrence count of an interval start endpoint and decrement the occurrence count of its endpoint plus 1, we are so what we are exactly doing? We are essentially marking the range of integers that lie within that interval. Then by iterating through the occurrence count array and keeping a running sum, we are counting how many intervals each integer lies within. Finally, by updating the most frequent integer whenever the running sum is greater than or equal to k, we are finding that integer that appears at least k intervals. Okay, I hope the approach is clear, the solution is clear, that how it is working. So now let me just write the code of it. So this is the code for that. I'll explain it again line by line what the things are done here. So again, the approach which I have told earlier and the one which I have showed in the example, same is written through the code as well. So here first we are initializing one variable called max endpoint, that is initially 0. Then after running through all the endpoints, we find the maximum endpoint. So what we are checking that for all rows, whatever is the value endpoint is occurring at index position 1. So we are getting the max endpoint from all those arrays. Then we are creating an occurrence count array with the size of max count plus 2. Max count plus 2 again just to include both the endpoints. That means the inclusive endpoint which is said in the problem statement, that both start and the endpoint are inclusive. So we are creating with that. Then after that we are iterating through the loop. Okay, and whatever is the starting point of each interval, increment the count for start of each interval. So whatever is the starting point of each interval, for that we are incrementing by 1, and decrement the count for each for the end of each interval. That means plus 1 to include the endpoint. So whatever is that value, whatever is the value we are getting in at endpoint, plus 1 to that. So that value we are decrementing by 1 for each interval. Okay, again just I'm explaining it again. Plus 1 is just to say that even the endpoint is included in the count. The element next to the endpoint, that is not considered, but definitely the endpoint is considered because it is inclusive. Okay, so once we have populated all this occurrence count array, so after that if you look, if you try to execute for the example which I have showed in this one here in notepad, so the occurrence array will look like this in this one. Then after that we are just having one variable called most frequent, that is initialized with -1, and running sum variable that is starting with 0. Now we will be iterating through this and from left to right for this max endpoint array. Up to from starting from 0 to the length of max endpoint plus 2, and we'll be calculating the running sum for all the elements that is occurring in the occurrence count. So whatever is the value starting from 0 till 30, yes, because it is starting from 0 and it is going up to 29 plus 1 30. Yeah, so so the total size will be 31. So starting from 0 to 30, so we will be counting the running sum, and at the point where the running sum becomes greater than or equal to k, so we will update the most frequent array with that index value. Okay, so initially for that example we'll see that wherever it first became 3, it was 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So for this one, for this 16, when we got the starting endpoint of 16, that the first time at that point the value becomes the running count sum becomes 3. So that satisfies the condition. So initially for the first iteration, whenever we replaces this this condition is true, so the most frequent value will be 16. Then after that we keep on checking for the further elements, and until this condition becomes true, we keep on checking, and we see that 21, for the given example, 21 is the most frequent element which we are getting in this one. That means till 21, this running sum greater than or equal to k, this condition is satisfied. After 21, when the value again decreases by 1, then the running sum count become 2. Then this condition will not be true. So after that, we just when this loop will terminated, whatever is the value contained in the maximum frequency, this is most frequent variable, that will be returned as output. Okay, I hope the solutions, even this solution is clear to you. So let me try compiling this code. So here you can see we have got correct output. Let's try submitting the solution. So this should not give the TLE error. So here we can see all the test cases are covered. It has not given any time limit exceeded error. So the first one which I tried with HashMap, that's why it is showing accuracy is 50%. So with this one, so this was the Java solution of it. So the time complexity of this code is big of n. If you look at all these things, then the first loop iterates through all the intervals and find the maximum endpoint value, which takes big of n time. The second loops iterate through all the intervals and update the occurrence count array, which again takes big of n time. The third loops iterate through the occurrence count array and calculate the running sum, which again takes big of n time. Since the occurrence count has size of max endpoint plus 2, where the max endpoint is the maximum endpoint value of any interval, the size of the occurrence array is big of max endpoint, which is at most big of n. Therefore, the total time complexity of this code is big of n plus big of n plus big of n plus big of n, which is in the order of big of n only. Okay. And space complexity is also big of n, because the occurrence array can be up to big of max endpoint, that will be in the order of big of n. I hope so even this time complexity analysis is clear. So even I prepared C++ solution, the same logic, only the syntactical difference, if you have anything, that is here. Here also the same thing, initializing one variable max endpoint, getting the max endpoint, incrementing the value by 1 if it is the starting of the set. If the endpoint, then we are decrementing by 1, endpoint plus 1 decrementing by 1, then calculating the running sum, and wherever the condition satisfies, we update the most frequent variable. And after this, till the point this condition is satisfied, we keep on updating the value of most frequent with I, and when this loop terminates, we return the value which is stored in this most frequent variable. So the logic is completely same. Let's try compiling this code. Sometimes it takes a lot of time for this to process itself. Yeah, so here we can see we have got correct output. Let's try submitting the solution. So here we can see even with C++ solution we have got the correct output. Yeah, so this problem has been solved successfully in both C++ and Java. So I'll provide the link for this question and the link for solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.